Welcome to G Fun Facts Online. What if the most advanced pharmacy in the universe wasn't on Earth, but scattered across the vast, cold expanse between the stars? And what if the greatest challenge for the first humans on Mars wasn't building a habitat, but surviving a simple headache because their aspirin had turned toxic? This is the world of astropharmacology, a field where the hunt for the origin of life and the future of human space travel collide, creating a revolution in medicine that will benefit us all. Let's start with the problem. The human body is a masterpiece of evolution, but it was designed for one place, and one place only: Earth. Take it into space, and things start to go wrong, fast. The most famous problem is microgravity. Without the constant pull of gravity, your body starts to decondition. Astronauts can lose up to 1.5% of their bone mass every single month. That's a rate of bone loss that on Earth we'd associate with severe osteoporosis. Muscles begin to atrophy, and the very fluids in your body shift, moving from your legs up to your head, leading to puffy faces, constant sinus congestion, and putting strain on your cardiovascular system. But the more insidious threat is invisible: cosmic radiation. Outside the protection of Earth's magnetic field, astronauts are bombarded with high-energy particles that can shred DNA, increasing the long-term risk of cancer and damaging the central nervous system. Now here's where it gets really tricky for medicine. These exact same conditions, microgravity and radiation, don't just attack the astronaut. They attack the pharmacy. The drugs we rely on are also calibrated for Earth. On the International Space Station, studies have shown that many common medications degrade far more quickly than they do on the ground. A drug that's stable for years in your medicine cabinet might lose its potency in months, or worse, break down into harmful, toxic byproducts. Imagine being on a 3-year mission to Mars and discovering your essential antibiotics are now useless, or your pain relievers have become poison. This is the urgent problem astropharmacology is trying to solve. How do we keep humans healthy when both their bodies and their medicines are failing in an alien environment? While one group of scientists is tackling this immediate, practical challenge, another group is looking to the cosmos for answers to a much deeper question: where did we come from? For decades, we thought the space between stars was a cold, empty void. We now know it's a bustling chemical factory. Using advanced radio telescopes, astrochemists have identified over 250 different molecules in these vast interstellar clouds. Many of them are complex organic molecules, the very same types of molecules that form the basis of life. We've found simple sugars, alcohols, and even the precursors to amino acids floating in the clouds where new stars are born. We get even more direct evidence from messages delivered right to our doorstep: meteorites. Certain types of meteorites, called carbonaceous chondrites, are like time capsules from the early solar system. The famous Murchison meteorite, which fell in Australia in 1969, was a treasure trove. Inside this single rock, scientists found over 70 different amino acids, the building blocks of proteins. They also found nucleobases, the letters of the genetic code in DNA and RNA. These are the fundamental seeds of life, formed naturally in space, without any biological processes. Recent discoveries have been even more mind-boggling. Scientists have found molecules like ethylene glycol, a key precursor to sugars, in the disk of gas and dust surrounding a young star, suggesting that life's ingredients are present even before planets have fully formed. The universe, it seems, is preloaded with the raw materials for biology. This is where the two sides of our story intersect and the true power of astropharmacology is revealed. The practical need for space medicine and the fundamental search for our cosmic origins are beginning to merge in incredible ways. The universe isn't just a potential source of life, it's a source of inspiration for creating better medicines. The unique and exotic molecules that form in the extreme conditions of space are forcing chemists on Earth to develop entirely new techniques. Take a molecule called carbene. It's a highly reactive chain of single carbon atoms. It was first detected in interstellar space decades ago, but it was so unstable that it was considered little more than a scientific curiosity. Recently, however, researchers figured out how to generate and control these carbenes in a lab. And what did they do with this new tool inspired by the stars? They used it to modify existing drug molecules. They've successfully used carbenes to add new chemical groups to the anti-cancer drug paclitaxel and the antidepressant duloxetine. This process allows chemists to fine-tune complex drugs in a way that was previously incredibly difficult, potentially making them more effective or reducing side effects. An idea born from staring at distant stars is now helping to accelerate drug discovery on Earth. But it gets even more direct than that. What if some of these molecules found in meteorites are not just building blocks, but have medicinal properties themselves? Meteorites contain a huge diversity of organic molecules that don't exist in Earth's biology. Each one has a unique structure, and it's entirely plausible that some of them could interact with our biological systems in useful ways. We could be sitting on an untapped library of potential new drugs delivered to us from space. While this research is still in its early days, it opens up a new frontier. The universe has been running a chemical experiment for 13.8 billion years, creating a